Okay, so today is our review day. I figured I'd start by seeing if there's any big picture questions, if we're clear on the test formats and all that kind of stuff, and then we can move on to specific problems if you guys have any, and if not, you guys can spend the rest of the time in class working on whatever it is you need to be working on. Isabel?
I'm just a little confused on how you're gonna break apart the test. I know you said the easier, shorter stuff, but what in specific would you be putting on?
So if we go and we look at the PowerSchool calendar, you'll find that I have posted assignments for those 2 days. Let's do it this way. And if I look at the individual assignments, I put in topics to kind of help guide you in terms of how this thing was broken up. So if I click on the part 1, you'll see that I have a bunch of skills kind of listed as things that you should be able to do. Okay. And if I click on the part 2, again, I have a much more specific list of things that you'll be able to do.
All right.
Okay. So basically the way I would look at it is the part 2 has just the long stuff on there. So vector story problems or force story problems. And then intersections for 2 lines, an intersection of a line and a plane, and an intersection of 2 planes. And I also have converting from the vector equation to the Cartesian form of a plane. That's a little bit of a longer problem as well. So those are the 6 things you'll have to be able to do on the part 2. And really anything else is kind of fair game for part 1. I tried to be rather specific when I wrote the bullet points for part 1, but that's kind of a good place to start. Does that help, Isabel?
Yeah, that does help.
You're welcome. Trevor?
I have a question for part 1.
Sure.
For the points you had, are points 1 and 6 the same exact concept?
Points 1 and 6. So convert between for 2D and 3D vectors, and then what is this? 1, 2, 3, 4, 5, 6. Find a vector equation of a line given 2 points. No. 7 says compute vector operations. No, what we're really talking about in number 1, though, is basically just converting between the different ways to represent a vector. And in number 2, you're looking at the different ways to represent lines or planes. So you should be able to write your answer in the form that I request for a problem, or be able to get the information you need from one form of to another. So if I give you a vector written in linear combination form and you're doing vector addition, you should be able to convert it into component form so you can do the vector addition kind of thing. And I don't know that any of those questions are going to be specific convert between them, but these are skills you need to have to be able to do larger questions or format your answer in a way that I'm looking for on there. Does that help?
Yeah, somewhat. So what would an example problem be for say the first point? Would it just be if you give us
So this points 1 and 2 aren't really directly problems, as more to do with getting the information you need out of a problem or writing your final answer for the problem. So I might ask you to here's vector u, here's vector v, do 3u plus 7v and write your answer in linear combination form. So you have to be able to do the vector addition, and then you have to be able to format your answer as a linear combination, which is probably not how you would do the vector addition, right? You'd probably use component form to do that.
Yeah.
So that's kind of what I mean in these, for bullet points 1 and 2. It's just being able to be comfortable with those different representations and how to get in between the different representations. Is that okay?
Yeah.
Does that help make you feel a little bit better as to what we're really looking for there?
I understand what you're looking for. I think I got it.
So
is it gonna be like similar to questions like the homework and worksheet?
yeah, where I just kind of give you some problems to do and ask for the answer in a certain representation is more kind of what we mean there. Or I give you some problem to do with a representation that maybe is not the most helpful way of representing that vector. And then you have to maybe rearrange it to get it into a helpful representation before you can really do the meat of the problem.
Okay.
So that's really what I was going for there, is that you feel comfortable changing those forms so you can get an answer in the what I'm asking for, or be able to take the problem that you're given and convert it into a form that's easy to work with. Okay. Raul, you had your hand?
Yeah. So will there be any story problems?
No. So all the story problems are in part 2. Yep. Again, I tried to put a few of the longer problems in part 2 and like most of the, shorter problems in part 1. Okay. Does everybody feel a bit better about the format there? And again, this is up here on PowerSchool, as you're kind of working on the review or whatnot, it might be helpful to look at that. All right. Do you guys have specific things that you wanted to talk about? Any specific problems or kinds of problems that we wanted to do another example of or run through the solution to or anything like that? I know I've checked a lot of homework today, and we've kind of talked about some of these assignments as we went, but if there's anything kind of dangling from any of these assignments that you still had questions about, or some of the things we talked about on Friday were quite complicated that if you wanted some follow-up on or whatever, I'm happy to do that now. Or if you just need me to shut up and let you work and you'll come to me when you have individual stuff, that's fine as well. Andrew?
Do you want converting the vector equation of a plane to Cartesian?
Sure. So I'm just going to make up some vector equation for a plane. I don't know if it's going to be how convenient or anything it's going to be, but I'm just going to make something up for the sake of doing this. I'm hoping that it's not going to be something silly and just end up as like a two-dimensional thing, but I don't think it will be. So here is my vector equation for my plane, right? Now this is an IB component form, but it wouldn't really matter as if this was in linear combination form or just regular component form or however that's represented, it's fine. It doesn't really change anything. My goal here is to get 3 points out of this. So I'm just going to pick some values for A and B to generate some points. So I'll use 0 and 0 to generate my first point. Then maybe I'll use 1 and 0 to generate my next point. And then maybe I'll use 0 and 1 to generate my third point. Okay with that, Andrew?
Yeah.
Okay. Now the Cartesian form for a line is ax plus by plus cz, where equals d, which a, b, c, and d are all integers. This has 4 variables in it. I'm going to kind of reduce the number of variables by dividing both sides by d. Oops. And then I'm going to think about the fraction a over d, b over d, and c over d just as a single variable. So now I have just 3 variables here, right? Notice none of them are directly capital A, B, C, or D, but they contain all the information I need to find those variables later on. So what I'm going to do is I'm going to plug in for x, y, and z, the x, y, and z from each of the 3 points that I found earlier. And that's going to form a system of 3 equations. So I have 3a minus 2b
You're late.
plus 1z equals 1. Hi, Gabe. And then I have 8a minus 2b plus 2z is equal to 1. Then I have 9a minus 5b plus 8z is equal to 1. I'm going to transform this system into a matrix in the usual fashion and use the RREF command on this to generate a solution. Oops. So I'll go and open up my matrix menu, go to the Edit tab, pick a matrix. Let's just use matrix A. So that's a 3 by 4, 3, -2, +1, +1, 8, -2, +2, +1, 9, -5, +8, +1. I'll exit out of there. I'll go back into the matrix menu, but this time going over to the Math tab, scrolling down to the bottom till I found the RREF command, and then going back and selecting that matrix A that we just made and using the RREF command on that. So I spit this out and it gets me some pretty crummy looking decimals. I don't really want a decimal here. I really kind of need a fraction. So I'm going to go into the Math menu and choose the fraction command. And that'll give me, or convert those decimals into fractions. Okay with that, Andrew?
Yeah, I just have a question, probably not according to the problem.
That's okay. Go ahead.
Did you mean like, in the three equations, put 2c and 8c?
Oh, yes, those should be C's. Thank you. Yep. Good point. Is that okay so far there, Andrew?
Yeah.
So what that system does is it tells me my values for my little a, little b, and little c. So what I'll do then is I'm just going to put those back into my equation. No, I'm going to, this is the equation with the little a, little b, little c. Oops. And now all I'm going to do is just clear the fractions. So what do I need to multiply both sides of this equation by to get rid of the fraction? 52, right? There's my final answer. Does that feel okay there, Andrew?
Yeah.
So again, not so bad once you've done it a couple of times. The calculator does the worst of it by solving that 3-variable system for us, because that's a pain to do by hand. But the rest of it is just kind of understanding what it is that you're working with, right? If you understand, like, okay, just need to get 3 points, and we need to solve this equation in 3 variables. And then basically the solutions to that equation are just tell me the coefficients for my formula, and it's not so bad, right? If you do that once or twice, you should be pretty comfortable doing that, as we use this same kind of approach several times inside of this chapter, right? So it's not so bad. The hard part is just kind of keeping everything straight. Is that okay there? Okay. That worked out better than I thought. I was afraid to get numbers in like the thousands for my fractions, but that wasn't so bad. Who's next? Do we have any others that we want to talk about like this? Again, I'm happy to do specific things, but if you're just like, I just need to work on stuff, that's fine too. Lindsay? 122 from the homework? Sure. So here we're looking at the intersection of, or looking at how these two lines interact with one another. Remember, there's 4 options here. You can have parallel, non-overlapping, overlapping, intersecting, and then non-parallel, non-intersecting. Regardless of the situation, the first thing we do is we want to check to see if they're parallel. And this is a pretty easy check. All I need to do is see if the one slope vector is a scalar multiple of the other slope vector. And it should be easy to see just by looking at the first 2 equations that they're not parallel, right? Since I get a different solution for k. That means we're either intersecting or non-parallel, non-intersecting. Okay with that? So the next thing we'll do is I'll check to see if they're intersecting. To check if any 2 of these objects are intersecting, all I'm going to do is set the 2 objects equal to each other. So in this case, I'm going to set R7 equal to R8. But that doesn't really change to see if I, like do 2 planes intersect or 2 lines intersect or a line and a plane or a line and a point. You just set the 2 objects completely equal to each other and then try to solve. So I did that. And this is going to create a system of 3 equations. So the first equation is 1 plus 2g equals 3 plus 5h. 0 plus 6g equals 6 plus 4h. And 5 minus 3g equals 1 minus 2h. Okay there? I'm going to just rewrite these so that everything is on one side. So I have g minus 5h equals 2. 6g minus 4h is equal to 6. And then minus 3g plus 2h is equal to negative 4. I'm going to convert that system into a matrix. Now, there's only 2 variables in this system, so I only need 2 equations. I'm just going to use the first 2 equations. It doesn't really matter which 2 equations you use, but you need to make sure you know which 2 you're using. And we'll do the RREF on that, and that's going to spit out a matrix that contains my solution. So let's type that in real quick. So 2 by 3, so 2, negative 5, positive 2, 6, negative 4, positive 6. Exit out. Go back in our matrix, do our RREF on our matrix A. So what this tells me is that G is equal to 1 and H is equal to 0. Is that okay so far, Lindsay? Okay. So the last thing I need to do to tell the difference between the intersecting and then parallel, non-parallel, non-intersecting is to check to see if that solution satisfies the 3rd equation. So negative 3 times 1 plus 2 times 0 should equal negative 4. That's not true. So because that check didn't work, we know we're not intersecting. So since we're not parallel and we're not intersecting, we're non-parallel, non-intersecting. Is that okay? If that check had worked out, and when I plugged in G and H, that equation was true, I would know that it is intersecting then, and I would need to go ahead and find the point of intersection. And that's easy to do. All I need to do is take the G or the H and plug it into the appropriate R7 or R8 to generate a point. If it had been intersecting, like if that check had worked. The way I finish that up then is to find the point of intersection using the solutions there. Okay? Does that feel good?
Yeah.
So the first thing we always do is we check to see if it's parallel or not. If it is parallel, I don't know if it's parallel or overlapping. So to check which one it is, you see if a point from one line is also a point on the other. If it's not parallel, we have to check the difference between intersecting and non-parallel, non-intersecting. So to check for the difference between two things intersecting or not, you set them equal to each other and see if that works. And that's the same for like all of these different objects, whether it's a line in a line or a line in a plane or a plane in a plane, that's still kind of the format we do. Okay. The plane in the plane one is a little different because we've only considering one situation. We just want to find their line of intersection because we decided the rest of it was going to be beyond the scope of this class. But for a plane and line, it's still kind of the same thing. Does that feel okay? Okay. Anybody else want to talk about things from... Okay, so let's stop here. I'll let you guys spend the rest of your time in class working